Do you look the same as you did 4.5 years ago? I sure don't. Now, imagine how much our solar system has changed over 4.5 billion years. So, how can we learn about what our solar system was like all those years ago? Find out next on Real World. One of the ways we can learn about the history of our solar system is by studying comets. You've definitely heard of some comets too. Do the names Halley, Schumacher-Levy, or Hartley-2 ring a bell? Well, there are thousands more where those came from. So, what is a comet? Let Dr. Paul Chodas, a research scientist at NASA's Jet Propulsion Laboratory, explain.
A comet is an icy small body. It contains a lot of dirt and other stuff in it, but it contains frozen ice. Mostly water ice, but there could be other ices in there. So the ice is very cold, of course, and when the comet gets close to the sun, the ice gets warmed up and it starts to boil off. And as it boils off, it forms streams of gases coming off, and these are what form the tail. They have been in the deep freeze. Many of them have been far beyond Pluto. They've been way out and gradually come into the inner solar system. And these objects contain not just the minerals of the early solar system, they contain the original ices of the early solar system. So if we study comets, we can learn about all of the materials that were there when the solar system was formed.
Cool! So comets are made of frozen gases, ice, dust, and rock. When the comet is far away from the sun, everything stays frozen. When it gets closer to the sun, it warms up, creating a coma. As it gets even closer to the sun's radiation pushes some of the coma away from the comet, creating the tail. So, if comets can be as far out in our solar system as beyond Pluto, or close enough to be seen by the naked eye here on Earth, how do we know how far away a comet is? Whenever you look at a distant object, you see the object's angular size, not its actual physical size. For instance, the moon isn't really the size of a quarter, it just looks like that because of its distance from the Earth. Angular size is the measure of an angle formed by extending two imaginary lines outward from our eyes to span the object. There's a simple formula that relates the actual size and the distance to an object to its apparent angular size. The tangent of the quantity theta divided by 2 is equal to d divided by 2r, where d is the object's diameter in kilometers and r is the distance of the object from the observer in kilometers. Not ready for that kind of math yet? That's okay. For understanding scale ratio, you can use a millimeter ruler and an image of a comet to set up a proportion and determine just how big that comet is. So, why should we care about what a comet is, how big it is, how it moves, or even how far away it is? Well, comets can tell us a lot about our early solar system.
The main reason to study comets is to learn about the conditions of the formation of the solar system. What are the materials that formed the solar system? What did it look like originally? We can't look at the planets, like the Earth, because it's undergone so much processing. Heating up, weathering, all kinds of things. All the planets have been processed heavily. If we take a look at comets, we can see the original materials from which the solar system formed.
And we have taken a look at comets with some really cool spacecraft. But how does someone like you or me go about getting involved in something this cool? Associate Administrator for the Science Mission Directorate, Dr. Ed Weiler's got the answer.
I have a message for any school kids out there who might be wondering how NASA can send a spacecraft billions of miles through the solar system and somehow wind up flying so close to a tiny comet only a few kilometers in diameter. It's done with math.
So a comet is basically like a really old time capsule, and as we learn about what's inside these time capsules, or comets, we can begin to answer questions like, where did we come from? And how did we get here? I don't know about you, but I wouldn't mind finding out those answers before the next 4.5 billion years pass. See you next time on Real World.